Razi, you don't come to the center? Don't you come to the center, Razi? Don't you come to the center, Madhuri center?
No, simply I'm not going to the center.
Okay, is it far from your home?
No, ma'am, it is not too far.
Okay, fine. Can you switch on your camera?
Okay, ma'am, can you give me 5 minutes so that I can make a place for my phone?
Yes, Shazan has to join and Advika too. So let me give them a.
Advika's already joined.
Advika has joined. Advika,
Yes,
you there?
ma'am.
Hello.
Hello, Advika. Advika, were you there in the last class? Hello, Advika.
I was.
You get too much of you get absent a lot, I guess.
Yes, ma'am. I have some exams going on right now. That day I had
Mhm.
practicals. Ma'am, I have exams going on right now. So that day we had practicals, so we had to stay back.
Okay, and when is the exam starting?
Ma'am, our exam starts on Monday.
On Monday, this Monday.
Yes, ma'am.
And when is the science? When is the science exam?
Ma'am, science is on Thursday.
Thursday. Okay. Thursday means on 15th. So, any doubt that you are having, because you know what, we have completed this chapter. Our chapter, all the means this course has already been completed in the last class itself. Okay. So,
Ma'am,
if you
I
are
don't
having
have.
doubt,
Ma'am, I don't have doubt.
don't have any doubt, means you can do all kind of numericals and all of the derivations,
Yes, ma'am.
law of conservation of momentum, or
Ma'am, it's
equations of
done.
motion.
Yes, ma'am. Ma'am, but conservation of law of momentum is deleted in our questions.
Yes, yes. Come again.
The law of conservation of momentum is deleted for us.
It's deleted
Yes, ma'am.
from the first semester.
Ma'am, just in the first semester it's deleted. The second semester will come.
Okay, and what about in gravitation? Mass is coming, right?
Ma'am, not first term.
Gravitation is not in the first term.
No, ma'am.
Oh my God, gravitation is not in the first term, and the last Shazan hasn't joined. Okay, fine. I will give some of the questions to you people, and you will solve them. Fine.
Yes, ma'am.
Let me know if you people have got mastered in this or not.
Maybe.
You should be, Adam. Okay, let me choose one. And this second topic is coming, right? The second topic is coming, and Razi, for you.
What are you asking something to me?
I'm saying the second topic is coming, no? Of law of motion.
Ma'am, the whole chapter is coming in this.
The whole chapter is coming in there. Yeah.
Yes, ma'am.
Okay, fine. Then do the sixth question first. Do the sixth question first, and then
Ma'am, can you zoom in?
zoom in.
Oh, thank you, ma'am.
Mom, I got it. It's 4.4 repeating.
What, Adam?
Oh my god, it's 4.4 repeating.
Okay. What about Razi and
Ma'am, is it 4.45? Ma'am, 4.45.
4.4?
We rounded off. Ma'am, 4.45 after you round it off.
Okay, fine. And what about this Razi?
Ma'am, I'm doing.
Okay, after sixth, do the 15th.
Which one, ma'am?
15th.
Okay. Oh, okay, ma'am. Ma'am, is it 1/2? Ma'am, for the sixth one, I got the answer 4.4.
Okay. And for the
Ma'am,
15th,
for the 15th one, I'm half by 2.
you have got your answer. No, you have got your answer, Advika.
Mom, I'm getting 1/2 meters. I'm getting 1/2.
1/2 you say, or 0.5 is the same thing, right?
Mom, the answer is there. I didn't say.
Let me give you the another one. Madam, tell me the Newton's first law of motion. What is the Newton's first law of motion?
Newton's first, like if an object is at rest, it will stay at rest. But if it's in motion, if it's in rest, it wants to be in rest unless it will be in rest unless another force applies on it. And if it's
unless an external force is applied.
Yeah, and if it's like moving, if
it is in motion, then
it's in motion. It will keep on going in motion unless an external force applies.
Ma'am, the answer for the sixth one is 1/2.
Tell me, Razi, what is second law of motion? Tell me what is second law of motion. Tell me what is second law.
Yes, ma'am. Second law of motion.
Yes.
Ma'am, the second law of motion, ma'am, it states that, ma'am, the object will move in the direction of the force applied.
No, not exactly.
Ma'am, I'm not able to define it.
Okay, can you tell me the relation that we use in Newton's second law of motion?
Yes, ma'am. Ma'am, force is directly proportional to change in momentum.
Obviously, so just say this thing in English. What it will be? The rate of change of momentum is directly proportional to the external force applied. It means the whole thing you will say is the second law of motion states that the rate of change of momentum is directly proportional to the external force applied. Okay, and also it takes place direction of in which the external force acts on the body. If we are, if this is a body, if this is a body, and we are applying force to it, obviously it should go forward, right? It will not come there.
Yes, ma'am.
It will not go backward. It will come forward. Okay. So it will be the motion is always in the direction of the force applied, right? So the change in momentum will to the direction will be what?
Ma'am, in which the
In
force
the
is
direction
applied.
of the external force applied. Okay. So Advika, can you define third law of motion? Can you
A
define
third
third
law
law
of
of motion?
motion or third of momentum.
No. Second law was law of momentum. The first law is called the law of inertia. The second law is called law of
Oh, okay.
momentum, and the third law is called action reaction flow.
Okay.
Action and
That is an
reaction.
answer. Now says that every action that is applied, there is an equal opposite reaction.
Yes. Okay. It means every what we can say in another term is every force is applied is
Ma'am has equal and opposite
apply,
reactive.
every force works in pair.
And it has
Right?
equal and
For
opposite
every
reaction.
force, we always have experience a reaction. For every action, we always experience a reaction. Okay. And using
Okay,
this
ma'am.
law only, using the third law of motion only, we use what? We use what? Using third law of motion only,
You
we
can say that.
derive the law or the formula for the law of conservation of momentum.
Conservation.
Okay. So you people can derive it now. No problem in deriving.
Ma'am, can you once derive it? Ma'am, I have a problem when we apply the another formula in it.
See, it's too simple. See, before collision, I've written this. Before collision, I've written this. M1 is moving with U1 speed, and M2 is moving with U2 speed.
You
Okay,
you
U2 speed. Okay, because initial velocity we take U. Okay, so for the mass M1, it's U1, and for mass M2, it's U2. And now they both get collided. Okay, they both got collided. So M1 and M2, I have showed them that they got collided. Fine. Now what? After collision, what will happen? M1 will start moving with some velocity, and M2 will start with moving with some velocity. Okay, so let it be V1 and V2. Okay, V1 and
Okay, ma'am.
V2. So V1 and V2 with their velocity after collision. Okay. So now using Newton's third law of motion. Using Newton's third law of motion. What is it? F1 is equal to minus F2. It's this now. Third law of motion is what? One action and reaction. F1 is equal to minus F2. Okay. So now what we are knowing that F is equal to ma from second law of motion. We are knowing this now. F is equal to
Yes,
ma
ma'am.
from second law of motion. So for A, can we write V minus U upon T?
Yes, ma'am.
We can write V minus U upon T. Now, already we have this relation. Already we are having this relation. F1 is equal to minus F2. Using this relation, M1, V1 minus U1, putting the values of V1, U1, U2, V2, these terms in this equation. Okay, so M1, V1 minus U1 upon T because it's for the time T. Okay, and minus F2 means minus M2, V2 minus U2 upon T. Now what we have left with? We are left with this T and T will get cancelled. Yes, no. T and T will get cancelled. Yes or no?
Yes, ma'am.
Why will it get
Yes,
cancelled?
ma'am.
How will it get cancelled?
Ma'am, because both sides it is given to.
Because
Sorry.
it's in multiplication. So with M1, the whole thing is in multiplication. So and the T is in division. So we can cancel these two. Okay, we can cancel these two, or we can also do it like this, that we can take this T to the right hand side, but it's very bachcha wala thing, so we need not to do that. Okay, just cancel it directly. Okay, now what we are left with? M1 just multiplied inside the bracket. M1 V1 minus M1 U1, M1 V1 minus M1 U1 equal to M1 V plus M2 U2. Why M2 U2? Plus why plus? Because this minus will get multiplied with this minus to become plus. Yes, now Advika? Yes, now I'm doing correctly now.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So rearranging this equation, what we will get? Just rearrange this equation. Take this minus kind of thing to the other side. This minus to the left side and this minus to the right side. Okay. So what we'll get? We'll get m1 v1 plus m2 v2 is equal to m1 u1 plus 2u. We'll get this. Now got this? Means total momentum. If you just reverse this equation, then what it will be? It will be m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v. Okay. So momentum we can write p. P before collision is equal to P after collision. Okay? It means total momentum before collision and after collision remains the same. Fine?
Yes, ma'am.
Okay. For Rika, this topic is not fun. Now, I think from the next class, we can start our new chapter, right? We can start the stuff for second term. Now, yes, from the from the next class, we'll be learning about Kepler's planetary motion. Okay, fine. Kepler's planetary motion. And were you there, Abhika, when I was discussing this first topic of gravitation? Were you there?
Yes, ma'am. Yes, ma'am.
Okay, fine. Then it's good. And also, Razi, if you understood this derivation or not?
Yes, ma'am. I
You understood that. Also, if you haven't understood, then you can go through the video that has been got uploaded at the extra video, not of the lecture, extra video that law of conservation of momentum. You watched that video?
No, ma'am, I have not.
No. I'm asking for Razi if has he watched this video that law of conservation of momentum.
No, ma'am. No, it's watched.
You have not watched it. You can go through that video. That video only that I created that video only. It's my video. Okay.
Oh, that one I saw, ma'am. That one I saw.
That one you saw. Yes.
मेरी गलती है ब्लेम कर लो बस
Okay. Now, what thing you want me to discuss today? Anything that you haven't understood, Ravi? Advika, you have understood everything.
Yes, ma'am.
But you didn't get you didn't get the marks, Advika. You got 20.5 out of 30 in law of motion.
Ma'am, that was because I didn't have enough time that time. I had something to do, so that's why. I only, ma'am didn't give me so much time to write.
But now you are prepared, right?
Yes, ma'am.
Okay. And for impulse, what do you know about impulse?
I don't know what is impulse.
You must know what is impulse.
We know what it
Tell me.
I know what it is in
Does
bio.
It's not pulse, it's impulse. It's not
Um,
pulse. Impulse. Pulse is in bio, no?
like change.
Razi, tell
in
me what
what? Is it change in momentum? I don't know.
What, ma'am?
what is impulse?
Ma'am, is
I
it
don't know.
momentum, change in momentum? Maybe I don't know.
Ma'am, it is written how? Ma'am, it is written impulse is equals to change in momentum, ma'am.
Oh, I didn't see that.
Impulse is equal to कितना force लग रहा है कितने time तक?
Oh, so ma'am, we can
Yes.
say impulse is equal to applied force.
For what value of time?
Oh, okay, ma'am.
Means for how much force is getting acted on a body and for how much time. When we multiply it, that is called impulse. Okay, means like someone is poking you. Okay, poking you. You understood this, right? Means someone has touched you like this thing from one finger, right? You must have understood what I want to say. So if someone
Yes.
is poking you, so he is applying kind of force on you and for a particular amount of time, right? For a particular amount of time. So if you will multiply that force with the time, then you will get to know that what impulse you got for that particular time, right?
Yes, or mass into the final velocity
Like-
minus into the
Like if we are standing still on a place, the gravitational constant is acting on us 9.8 newtons, and like we are standing for 30 seconds. So we'll multiply 9.8 into 30 and we'll get the impulse.
9.8, why? 9.8?
From 9.8
equal to
newtons.
MA. Yeah. So you mean
yeah.
that F is equal to MA, you want to apply the formula like MAT, right? Mat.
Yes, ma'am.
Mass into acceleration into for what value of time. Yes, that will be the impulse, but it will give no effect to the earth.
Yes,
It will
ma'am.
give no effect to the earth.
Right.
Okay, because it's if you are standing on a sand, then you can say that then you can figure out that what distance you have penetrated
Yeah,
when you
that
have
is
when
what
you
I'm
have
but that is only if you have like a pile of sand.
pile of sand, if you are standing on a, or you may sand dunes, if you are standing on a sand dune. So in sand dune, what is it like? It's like, this is a sand dune, right? A very small hill of sand, very small hill of sand, right? Very minute hill of sand. So if you are standing on this, like this is Advika, okay? Advika is standing on. So Advika is standing on this sand dune. For some mass, let her be mass be 25 kg, okay? Advika, is it so? 25 kg?
No, ma'am.
Advika, then what kg
Hello.
should I take? Yes, what kg should I take of you?
Ma'am,
50
42.
kg. 42. Okay.
Papa.
42 kg. So 42 kg, Advika is standing with the acceleration. What? With the acceleration what? With the acceleration, let it be 10. Okay, we know we don't want to do kind of calculation. So let it be 10. Okay. So
Ma'am, so
10
if you
and
use
what?
10, ma'am, if you use 10, what our answer would be accurate?
Yes.
Ma'am, if you use 10, our answer will be inaccurate, right?
The answer will be yes. It will be accurate. So, but in the exam, if you are not given that you can use the value of G as 10, then you will use the value of G as 9.8. Yes. So by default, you have to take the value of G as 9.8. But if it is given in the question that you can use the value of G as 10, then you can use. Okay. Fine. Now 42 into 10 into what? Into for what are you time should we take? For 5 minutes. Okay. For 5 minutes means if we convert it into second, then what we'll get? What we'll get? Second.
60,
300.
300.
300 seconds. We have to convert this into second. Okay.
And
So
you know,
42.
no, it should be 3000, right? 15 to 60.
So what impulse will Advika apply on that sand dune? 42 into 10, 42 into 3, what it will be? 2, 2, 3 is 6 and 4, 3 is 12. 126,000,000. Okay. So what the unit will be? What the unit will be? Tell me. It will be what? It will be what? Force into time. Force is Newton. Newton. Force is Newton. T is
Yes, ma'am.
second. So the unit will be what? Newton second. Okay.
Okay, ma'am.
And you can also write it in this way, the standard way, 1, 2, 3, 4, 5. 1.26 into 10 power 5 Newton second. Okay?
Okay, ma'am.
Okay? Okay. तो impulse नहीं आता था ना तुमको रजी कहीं से?
No,
भूल
ma'am,
गए?
now I got.
Okay. Any topic? Tell me any topic you are having problem in any of the gravitation, universal law of gravitation. Yeah, gravitation की value, what is the gravitational constant?
I was like 6 point something.
9.8 meters per second.
Ma'am, 9.8
No, no,
Newton.
no, no. I'm not asking you the
Universal
acceleration.
gravitational constant.
Universal gravitational constant, not
No, that's
acceleration due to gravity.
6.76 or 24
Into 10 power?
into 10
What?
power
Minus 10 power?
negative 11.
Minus 11. Negative 11.
Negative
Yes.
11.
And if someone will ask you to derive the unit for universal gravitational constant, then derive the unit for universal gravitational constant, then
I would not know what to do.
Hmm?
I would not know what to do.
you don't know what to do. Just apply the formula. What is the formula? What is the formula? F is equal to G M1 M2 by R square, right? So you have to figure out the unit for G. Just leave the G alone. Leave the G alone. Okay. So in order to leave the G alone, what you have to do? You have to bring all of the other things to the other side. Okay. So F R square by M1 and M2 multiplied together. Okay. So F is what? Newton. R square is what? Meter square. M1 and M2 will be what? This is also kg and this is also kg. So what we are left with? What we have got? Newton meter square per kg square. Yes or no?
Yes.
Yes or no?
Remember Tarzan told it.
Yes.
And Arhan, you were saying कि हमको नहीं आता है. Newton meter square per kg square. Okay. Not 2 times. Okay. So first you have to write, if you have this relation, first you have to write this equation. F is directly proportional to M1 and M2, masses of both the objects. Okay.
Yes, ma'am.
And also it's inversely proportional to the square of the distance between them. Square of the distance between them. F is proportional to the 1 by d square. Okay. Now what we have to do? We will combine both of these equations, m1 m2 by d square. F is proportional to m1 m2 by d square and then equal to sign, because this is the what? This is what? This is culture. This is culture. What is culture? That to convert this proportionality sign into equal to. And if we are going to convert this proportionality sign to equal to, what we have to do? We have to add something to it. What it will be? It will be G. Okay? It will be some constant. Because there is also some of the values that we are not knowing, that we have to figure it out. And it is also, the force also depends on something else other than masses and what? Other than masses and say
Distance.
Other than masses and distance. Yes. Other than masses and distance. So it's what we have got. We have got this G, and we have got this value for G as this 6.67 to 10 power minus 11 Newton meter square per kg square. Okay. When we and you see one more thing, that if we are using, if we are comparing something, means want to know about the force between an object and the earth, then we always take the distance between the object and the earth as the radius of the earth. We will not consider the distance at which the object is kept from the earth surface.
Yes, ma'am.
Okay?
We did a question like 2 kg object is kept on the Earth's surface.
Yes, because it's totally negligible, right? That distance will be negligible in front of 6400 kilometers. Okay, whether no matter if it is 1 kilometer, so it will not worth. Okay, for MIL everything is done. Graphical representation. अच्छे से आता है ये सारे graphic representation.
Ma'am, I have a question.
Yes.
Obviously, ask.
Ma'am,
Aram will
Ma'am, in
answer.
our daily
Aram will
life,
answer.
ma'am, in our daily lives, we just calculate the distance, ma'am, like from surface to surface. In physics, why do we calculate like from radius to the radius of the another object?
Come again.
We calculate from the center of mass.
We
Ma'am, my
calculate.
question was, now in our daily lives, we calculate like the distance from surface to surface of one another objects. But in physics, why do we calculate like the distance between the objects by their radius? Why can't we like calculate the distance from the surface to surface?
Because we are actually taking it from the center of mass. We have to include the center of mass also.
Okay. Oh, see, yes. It is an object and it is an object. Okay. The distance between these, take the distance between them. We can even take this distance. We can even take this to this distance. We can take many of the distance. We can take this distance to this distance. So this distance you will take. Which
From the
distance you
center
will
of
take?
mass.
Better to take the distance between their centers. This is an object and this is an object. Just
From center of mass, not
find
exactly.
it. Yes, center of mass. So find
Because
it.
if there's more
find
mass
it.
this side, less mass this side, then it would be a little bit.
Center of mass means where all the masses of that object means most of the mass of that object resides. Okay, जहाँ पर सबसे ज़्यादा mass जो होता है वो reside करता है, so उसी को कहते हैं center of mass. Okay, human body की कहाँ पे रहती है? Human body की where is it?
Is it like somewhere near the tummy or something?
Yes, near the tummy. Yes. Belly button. Okay. Yes, maybe not. Yes, it is. Yes. Okay. So this is the center and this is the center. Now you see, these are the two objects, and we will be finding their it will be having mass some m2, and then this distance will be d somewhat. Okay. Then if we consider Earth, Earth is very big, right? You see, even if you consider Mars, even if you consider Moon, then also you will take the radius of that Earth or Moon or Sun, fine, as the distance between the objects. Because if you consider an object will be nothing in front of Earth or any other planet or star. Okay, it will be nothing. So this distance will be regarded as negligible in place of this. This is the radius of the Earth, because the center of mass of the Earth will be in the center of the Earth, right? Center of the Earth. So it will be we'll take the radius of the Earth. Okay, radius of that. And if we take radius of that object, that will be what if we also consider the radius of that object along with the distance it is far from that earth, so it will be just negative. Okay, you consider
Yes,
it
ma'am.
or you don't consider it, will be equal. Fine. This is why we take radius in whenever we talk about celestial body. Okay, whenever
Oh,
we
okay.
talk about celestial body.
And
So
ma'am,
clear?
yes, ma'am.
Say.
So since it's we take from the center of mass because like the force of gravity always points towards that direction, right?
Again,
Like
again.
we always use the center of mass because the force of gravity always pulls us in that direction only, right?
Yes. Okay. So we can close the class for today.